Hello, my name is Erica Kleinman. I'm a PhD candidate at UC Santa Cruz in the Game User Interaction and Intelligence Laboratory, and I'm here to present our paper, Kills, Deaths, and Computational Assists, Identifying Opportunities for Computational Support in Esport Learning. Recent work has demonstrated that playing esports, especially at high skill levels, can have real-world benefits. For example, previous research found that high skill level esports players demonstrated significantly higher fine motor skills and emotional regulation skills than their lower skill level counterparts. Because of this, esports are seeing increased implementations in serious and high impact domains, such as schools, where they have demonstrated the ability to improve students' academic performance. The problem, however, is that becoming a skilled esports player is not an easy task, and players who do not belong to established communities are forced to learn on their own, which can be extremely challenging. In such circumstances, training can be rife with uncertainty and feelings of inadequacy, which can result in frustration and discontinuation of play. This ultimately makes the benefits of esports play inaccessible to those who do not have access to a support network and who may not be able to learn easily on their own. To help players overcome obstacles and learn to play faster and more efficiently, many companies and research groups have developed computational tools for esports, including artificially intelligent assistants and visualization systems. Despite the abundance of research and tools, however, there remain open questions regarding players' specific needs and how they can be addressed through computational support tools. This is due to a lack of a comprehensive understanding of how players go about learning and mastering play, and how this can be supported computationally. You see, most existing work looks at the skills that expert players possess rather than how they obtain those skills, which makes it difficult to support players on the road to mastery. So, this study sought to address that gap by asking two research questions. What are esports players doing to learn and improve at play, and what challenges are they facing as they do so? We argue that by answering these questions, we can better inform the design of computational tools meant to support players on the process of becoming skilled at esports. To answer these questions, we conducted an interview study with 17 esports players who had experience playing 14 different games. In addition to questions about their goals and how they try to reach them, we also had them participate in a hypothetical design exercise where we asked them to describe their dream computational tool. We did this because we could extract information about what they're doing or facing from these designs. And this data was analyzed using an iterative thematic analysis protocol, once for research question 1 and a second time for research question 2, by two researchers. More information regarding the demographics of our participants and the details of these methods can be seen in the paper. The results revealed 4 activities that players engage when trying to become skilled at esports, and 4 challenges that they're facing. Starting with the activities. The first one, practicing, refers to the act of playing the game, and while inherently obvious, participant responses discussed a variety of ways that they practice, ranging from just repeatedly or constantly playing to using dedicated practice modes or AI opponents, and participants seem to view practice as an opportunity to build a stronger game sense or understanding of the game's mechanics and rules. The second activity, leveraging the knowledge of others, captures the role that other players play in an individual player's journey to improvement. In some cases, the knowledge of others came directly from teammates, training partners, or coaches, and in others it was obtained more indirectly through streams, videos, or written guides. The third activity, tracking performance, relates to the different ways that players are tracking their level or overall score over time. Participants discussed using post-game statistics, official ranks, or achievements alongside external tools that aggregate and archive gameplay stats over time. Some participants even mentioned creating their own records, tools, or databases to track their performance personally. The last activity, reflecting on gameplay and setting goals for the future, revolved around the ways players identified mistakes that could be addressed in future play through review of and reflection on their gameplay and gameplay data. They also discussed setting goals to work towards, and both of these relate to the phenomenon of self-regulated learning often discussed in learning sciences. Following this, there were also 4 challenges. The first, coordinating and collaborating with teammates, encompasses discussions of the difficulties that players face when attempting to work with others. In some cases, those who played on teams discussed challenges related to communication and keeping track of teammates. These were sometimes exacerbated further due to the toxicity in the game's communities. In other cases, participants discussed challenges even finding someone to play with, and this was especially concerning for those who discussed the importance of working with a dedicated training partner. The second challenge, knowing what to do next, encompasses all of the difficulties players discussed facing when making decisions. This primarily applied to discussions of real-time decision-making, with participants articulating how difficult it could be to know what the best course of action in any given situation was. Despite this being a challenge, however, participants in our sample also showed an aversion to a tool that would explicitly tell players what to do. This was due to concerns of cheating or unfair advantages, loss of control or agency, and fears that a player would not learn to play on their own if they used such a tool as a crutch. The third challenge, tracking game state, relates to tracking what is happening in-game, and players' ability to track the larger context of play. In some cases, participants discussed difficulties with spatial awareness, specifically in terms of tracking where other players' objects or objectives were located. In other cases, participants discussed difficulties keeping track of resource information, such as the number of cards in a deck or enemy health. Notably, however, participants also expressed an aversion to any tool that would give them information they would not otherwise have access to, expressing concerns that such support would constitute cheating. The final challenge, tracking skill and improvement, encompasses difficulties that players faced when trying to understand their own talents as a player. Participants expressed that it was often difficult to know what they were doing wrong, which could lead to repeated failure without knowing why. While some participants expressed a desire for an objective evaluation or grading system that could address this, others discussed concerns about receiving inaccurate evaluations or an evaluation that did not match their own judgment of their performance, and expressed hesitance to trust a tool to do so. Based on these results, we identify 6 primary implications for future design and development. Evaluations provide context for understanding tracked data. Explanations may be necessary to promote trust. Players require practice partners that play like real people. Real-time data tracking can act as an alternative to proper communication. State tracking can improve situational awareness and game sense. And computational tools can use scaffolding and co-regulated learning to support decision-making without becoming a crutch. I unfortunately don't have time to discuss these in detail in this presentation, but in the paper we expand on each of these and discuss them in terms of what they mean for the design of future computational support tools for esports. Thank you for listening.